It's been a while since AWS Lambda supports .NET 8 runtime. In this video, let's learn how to build a Lambda function using .NET 8 and see what's new. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is part of my .NET Lambda series and is sponsored by AWS. If you're completely new to AWS Lambda, I highly recommend checking out my Getting Started with AWS Lambda video and also my Udemy course on AWS Lambda. Both the links will be in the descriptions below. Before we head into code, let's quickly see what's new with AWS Lambda and .NET 8 runtime. The .NET 8 runtime is built on the Amazon Linux 2023 minimal container image. Now this is a smaller deployment footprint and also has the updated versions of common libraries. Lambda has increased the default memory size from 256 MB to 512 MB in the blueprints and templates for improved performance with .NET 8. So when you create a new Lambda function, you will see that by default, the memory is set to 512 MB. One of the biggest changes with the .NET 8 runtime support is the native AOT support, which is the ahead-of-time compilation. This allows .NET applications to be pre-compiled to a single binary, removing the need for just-in-time compilation. This means the cold start times are much improved. By enabling native AOT, apps are able to start faster. Now, benchmarks show 86% of improvement to cold start times by purely eliminating the JIT compilation phase. We will see more on this later in this video. And don't forget, the .NET 6 end of life is almost near, so that would be a very good reason to migrate your .NET apps on AWS Lambda to the .NET 8 version. So let's switch over to Visual Studio and see how to get started building an AWS Lambda function and see some of these new improvements in action. Let's choose Create a New Project in Visual Studio and search for AWS Lambda. So inside here, you can search for AWS platform and also filter down by the Lambda function. So you can select Lambda, which will give you all the project templates that's associated with AWS Lambda. Now in here, I have lots of templates because I have installed the AWS Toolkit. Now the AWS Toolkit is an extension that you can install on Visual Studio and also JetBrains IDE and Visual Studio Code. Now this provides a lot of additional functionalities when developing AWS applications. I highly recommend checking out my Getting Started video and also setting up AWS for the local environment video, which will be linked in the descriptions to learn more about the toolkit. Now, the template type that we are interested in is the AWS Lambda project .NET Core C#. It has the Lambda icon right next to it. So let's select this and click Next. Now, this prompts you to enter the project details. So let's give this a project name. So let's say Hello .NET 8 Lambda. Let's make sure it's in the appropriate location and click Create. Now this prompts for the select blueprint, which is the different templates that this supports further to choose a Lambda function. Now you can see this gives you different options to select the default Lambda function that will be set up in the template. Let's choose empty function for now. But based on your application and needs, you can choose one of the other template types that provides integration with other AWS services as well. With empty function selected, let's click Finish. Now this sets up the AWS Lambda function project template and starts off the Visual Studio with the application code. Now here we can see the main files, which is the function.cs and the AWS Lambda tools defaults.json file. Now the function.cs contains the function code that will be executed when the Lambda function runs, and the AWS Lambda tools is the default configuration file for the mock Lambda test tool. This is also used by Visual Studio when deploying the Lambda function using Visual Studio. Now, if you look at the functions.cs, this is very similar to the previous versions of .NET Lambda functions. We can see that the function has a function handler, which simply takes in a string and returns it in uppercase. Now, we also have the Lambda serializer specified on the assembly attribute, which supports JSON serialization for the payload. We will see an example later in this video. Now, by default, this has the mock Lambda test tool set up, and that's set up using the properties and launch settings.json file. So you can see here, this is set up to executable and points to mock Lambda test tool. So this simply runs a .NET Lambda test tool, which is installed as a .NET tool. Now, if you want to learn more about launch settings.json file, I highly recommend checking out my video linked here and in the descriptions below. So let's run the Lambda function and see this in action. So we will run this locally in my development machine, and this launches the .NET 8 mock Lambda test tool. Now, this is very similar to the previous versions of Lambda test tool. We do have some additional functionalities on the Lambda test tool across in the sidebar, which I will cover in a future video if you are interested. Let me know in the comments below. Now, this specifies the entry point for our Lambda function, which is pointing to our function handler in the function class. So you can see there is the namespace defined and also the assembly name specified in here. So the first part is the assembly name, and then the namespace, and then the class and the actual function in that function name. So if you switch back, you can see that the function name is function handler. This is what is getting wired up as the function startup code. Now, this has by default selected the credential profile to run this again. Let's specify a string input. So let's say hello world and execute this function. Now you can see here this responds back in uppercase the hello world that we have specified. So our Lambda function is up and running. Now, if you want to use a more complex type instead of the string, we can do that as well. So let's create a new class inside here. So I have a data class which has key1, key2, and key3 properties. Now, instead of the string input, we can take the data as the input type. Now, in this case, let's comment this for now, and let's put in a different return string. So let's specify the input key1, key2, and key3 and return back those details. So let's build and run this and see this in action. Now, in this case, we need to specify a JSON document which has key1, key2, and key3. You can choose the example request and specify the hello world request. So this has the key1, key2, key3. So let's click execute function. And in this case, you see that we get the value 1, value 2, and value 3 back. Now, if you want to change these, so let's specify Rahul and let's click execute function again, and you can see this is returning the values as expected. Now the JSON serialization is supported because we have explicitly specified the Lambda serializer and using the default Lambda JSON serializer. Now if your Lambda function uses an input or output types other than a stream object, you must add a serialization library to your application. Now if we haven't specified this, then this data input conversion wouldn't happen. So if I was to comment this out and run this again, you will see that this will fail if we pass a JSON input, because the Lambda function will expect a stream input by default when you have not specified a serializer. Now you can see there is an exception, and it says object of type memory stream cannot be converted to type the data class that we have specified. This is why the default serializer is being specified at the assembly level. So let's switch this back to the string input and let's comment this out as well and return back to our function, which simply returns the data in uppercase. Let's deploy this Lambda function into AWS environment and see this in action in there. Now in this case, I'll deploy it from Visual Studio. So let's right click on the project and say publish to AWS Lambda. Now many of these details are by default coming up from the AWS Lambda tools defaults.json file. So in this case, let's create a new function. So let's specify the name as hello.NET 8 Lambda. And let's click next. Now you can see here that the memory is by default to 512, which you can change. The timeout is 30 seconds. And also you can specify the role that this AWS Lambda should be assigned. So let's choose one of the predefined roles, which grants it the basic execution role that allows it to write to CloudWatch logs. Now, since this Lambda function does not talk to other AWS services, you don't need further permissions for this. Now, I have various videos in my AWS Lambda series that covers integration with other AWS series. Check that out if you want to learn more about those. So once you have specified this, let's click upload, which starts the upload process. Now you can see here that this is setting up the IAM role, packaging the application and uploading this as a zip file and running this inside the Lambda environment. So you can see this is using the .NET publish to build the output package and will use that to upload to Lambda function. Now the upload is complete. So let's close this dialog and you have the Lambda function details inside Visual Studio itself. Now, if you want to invoke it from here, we can do that. So let's specify hello world, and let's click invoke. Now this is going to invoke our Lambda function and return back the result in here. So you can see the hello world response here in uppercase. You can also see the log output the Lambda function has returned to CloudWatch, and this shows the build duration and also the initialization duration. So the init duration represents the cold start time. In this case, this has taken 238 milliseconds to start this Lambda instance. And you can see the total duration of execution is only 175. Now, if I invoke this function again, you can see this time the init duration doesn't appear in the logs. This is because the Lambda function instance is already created and that is getting reused to serve this specific request. Now, if you have a sudden burst of requests to the Lambda function, it will automatically scale up and create more instances. Now, I highly recommend checking out my Lambda lifecycle video to learn more about the Lambda lifecycle and how the instances are created and maintained in the AWS environment. Now, if we keep invoking this, you can see that this build duration switching over from 2 milliseconds to 3. So it's approximately taking around 2 to 3 milliseconds to invoke this function now. Now, if I switch over to my AWS console, you can navigate to Lambda and see the Lambda functions. Now, I have various Lambda functions inside here, and here you can see the hello.NET 8 Lambda function. So let's navigate into that, and you can see this is runtime.NET 8, and you can also see the handler that is using for this specific .NET function. So this is the exact same handler that we saw in the mock Lambda test tool. Now, if you navigate into test, you can test the Lambda function right from here. So let's specify a text inside here. Let's remove this and let's specify hello world, and let's click invoke from here. Now this shows the details right on top, and you can see the response coming back, which is hello world in uppercase, and you can also see the logs inside here. Now if you want to see the CloudWatch logs, you can navigate to monitor and select the CloudWatch logs. This opens the default log group that is set up for that CloudWatch log, and you can see the log streams and the log messages inside here. So you can see the init duration for the first instance and that the next invocations doesn't have the init duration. This is because the same Lambda instance is being reused. .NET 8 supports native ahead of time compilation. So when you deploy a .NET Lambda functions without using AOT, which is the one we just saw, the application is first compiled into intermediate language code. At runtime, the just-in-time compiler in the Lambda runtime takes this IL code and compiles it into machine code. However, with native AOT support, you can do this ahead of time and pre-compile the application code into the machine code. This means you will need to build the application code so that it can run on the Amazon Linux 2023 operating system. So this is done using Docker and creating a build for that image. So let's see how we can set up a .NET AOT Lambda function and publish this to AWS Lambda. So let's come back to our Visual Studio. Let's right-click on the solution and specify add and say new project. In this case, we'll again select the same template type, which is the AWS Lambda project. Click next, specify a name. So let's specify hello.NET 8 Lambda AOT, and let's click create. Now when the blueprint selection prompts up, you can choose the .NET AOT version of the blueprint. Now this sets up the template so that it supports native AOT, and let's click finish. Now the project is created, so it has the same files, which is the function.cs and also the Lambda tools default JSON file. So let's navigate into the function.cs, and here you can see that there is a slight difference in the function setup code. So we have an additional main function which is wiring up the actual function handler. So inside this, you can see the function handler, which again is simply a function that takes in a string input and returns that in uppercase. Using that function handler, the Lambda bootstrap builder is used to wire up the Lambda runtime. So the main function is the entry point in this case, and it uses the Lambda bootstrap builder to start up the Lambda runtime. And it passes in the function handler and also the source generator Lambda function JSON serializer to specify the JSON serializer. So this is a slight difference. In this case, the main function is the entry point and the Lambda runtime is bootstrapped within the code itself. So you can see this, the main function is called only once during the initialization phase of the .NET Lambda runtime. Again, refer to my lifecycle video if you want to learn more about these phases. Now, if you want to see the other differences for the Lambda AOT function, you have to check the project file. So let's open the csproj file for the Lambda AOT, and let's also open the csproj file for the normal Lambda function. So let's open this in two different tabs. So let's make this in into a vertical document group so that we can compare these two files side by side. Now, in this case, you can see the Lambda AOT has additional attributes in the CS project file. The publish to AOT is true in this case, which does not exist in the normal JIT compiled Lambda function. It also specifies the configuration for the assembly trimming, so you can see the strip symbols to be set to true and also the trip mode to be set to partial. Now, if you want to learn more about these properties, let me know in the comments. I'll do a separate video on the ahead of time compilation and the trimming mode supports. So these are the three main properties that's different from a normal JIT compiled Lambda function. You can see that the publish ready to run is true inside here. However, that is not specified inside the AOT project. Now let's deploy this AOT supported Lambda into our AWS account and see this in action. So let's again go to the Solution Explorer, right click on this project and say publish to AWS Lambda. So let's create a new function. Let's specify hello.NET 8 Lambda AOT and let's click next. This provides the same options to select the role. So let's choose the basic Lambda execution role so that it can log to CloudWatch. You can see the memory is still 512 and let's click upload. Now this is going to upload the Lambda function into our AWS account. However, note that while building this application, this is going to use Docker. This is because it needs to pre-compile the application into the image that AWS Lambda runtime uses. So here you can see the starting the container for native AOT build using this specific image, which is the public ECR image and .NET 8 latest Lambda x86 64. So this is using this image on my local Docker to compile this application. So you can see Docker run, it's setting up the build and it's generating the native code that needs to be published. So the deployment is complete. So let's close this dialog and you can see that it prompts up the Lambda function. So let's close this additional tab and let's invoke this Lambda. So let's specify hello world and let's click invoke. Now this returns a response and you can see the init duration inside this. So this is subsequently lower than the previous init duration that we saw. So if I switch back into our CloudWatch, you can see the init duration was around 238.65 milliseconds with the normal JIT compiled Lambda function. However, with the AOT enabled, it is only using 107.6 milliseconds. Now, a subsequent request as before is not going to have init because it is reusing the Lambda instance. And you can see the total duration to invoke this is also subsequently less, which is around the 1 millisecond. So if I right click on my project and say show folder in File Explorer, let's navigate into the bin folder of this Lambda function to the release .NET 8 and the publish folder. You can see here the pre-compiled AOT files or images that is going to be deployed to the Lambda function. So you can see we just have one file which is ready to run in the Lambda runtime. However, if I switch back to the other Lambda function, so let's go to the hello.NET 8 Lambda bin folder, the release .NET 8 and publish, you can see this contains the DLL files and the other files that's associated with that because this is going to be JIT compiled in the AWS Lambda runtime. If you want to see a more detailed performance comparison between the .NET 8 normal version and the ahead of time version of Lambda functions, let me know in the comments below. I will do a video to cover that topic. I hope you liked this video and was able to get started using .NET 8 on AWS Lambda. If you like this video, please make sure to hit the like button. And if you want to be notified of future such videos, make sure to hit that subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.